Today we are going to start very important topic, okay, that is dimensional analysis. Dimensional analysis, dimensional analysis. Okay. So what is dimensional formula, okay, or what are the base quantities or fundamental quantities, base or fundamental quantities, okay. What are those? Already we have discussed. Important is mass, okay, length, then another is what? Time. These are the three main. Then thermodynamic temperature or simply temperature, thermodynamic temperature or simply temperature we can say, thermodynamic temperature, 1, 2, 3, 4, then current, current is also fundamental quantity, then luminous intensity, okay, then amount of substance, yes, 1, 2, 3, 4, 5, 6, 7. What are the notations? This can be described by capital M, this case is described by symbol is time, this is length, this is theta or Kelvin, this is A or I in some book, and luminous intensity, symbol is candela, unit is candela, so symbol is CD, amount of substance, mole, symbol is mole, okay. This is meter, meter written as M, this is a mass, no, kg, this unit is what? Kg, kilogram, then this is a meter, SI units, meter, second, this is what? Kelvin, Kelvin is the SI unit. For this ampere, small k, small k, then ampere, okay, then candela, then mole, and these are the symbols. So, in the symbolic format, if these are mentioned to describe a physical quantity, normally we use this fundamental base quantities. Suppose you want to express speed, speed is what? Distance, distance upon time, yes or no? So, distance is what? S upon, distance means what? Length, T means time, okay. So, this is L, this can be written as T1. So, dimensions of speed, normally we write speed as a U, suppose, so this, in this way we can explain this derived quantity by using this fundamental quantity. This is a dimensional formula for speed, in a square bracket this is written, okay. So, like this. So, this how many this is constituted with these two fundamental quantities, base quantities. With the help of these two base quantities, this derived quantity is obtained, right. So, this distance is, so this L and L to the power here 1, T to the power minus 1. So, we can say this 1 is the dimension of the speed in terms of L. The financial condition of that person is good, financial condition of that person is good, speed, 1 is the dimension of speed in terms of L, like that. So, minus 1, the dimensions of speed is minus 1 in terms of time. So, like this you can explain, okay. But normally we take all these three, and remaining also we can take if they appears in the formula, okay, then we can take this. But these three are, though it is present or not present, here mass is not there, okay, but we have to include mass, no mass, so 0, so power of m to the power of m is 0 means 1, and 1 multiplied by this, no problem. So, you can write m to the power 0. So, L1 t to the power minus 1. In this way the dimensions are written. These 3 physical quantities are taken, though they are present or not present, no problem. This is also correct. Whatever physical base quantities are present, that much you can take like this, no problem. But normally mass, length and time are taken. If present, then that power, if not present, then 0 we can write. So, dimension of speed in terms of mass is 0. Okay. Now, look. So, if you want to define dimensional formula and dimensions, what we can write? What we can write? Dimensions, first dimensions. So, dimensions are what? This is not dimension, power is the dimension. Dimension of speed is 0 in terms of mass, dimension of speed is 1 in terms of length, like that. So, the powers of the base quantities or fundamental quantities, base or fundamental quantities that to be raised powers that to be raised on base or fundamental quantities are called dimensions, are called dimensions. Getting? So, these powers are called dimensions. Okay. And what is dimensional formula? Dimensional formula. Normally it is written as df, short form. We are habitual to do short forms of anything. Pj. Yes. Then RIP, rest in peace, RIP, RIP, like that, anything. So, like this, df is a dimensional formula. Now, look. So, this is the expression, dimensional formula means what? Expression of a derived quantity in terms of base quantities to describe its unit. From that you can understand the unit. So, L is 1 means meter 1, T means second minus 1. So, meter per second. Mass 0. So, kg is not there. So, like this. So, from this dimensional formula you can understand units. Reverse also you can do, if you know the units, from the unit you can find the dimensional formula. But purpose of writing this dimensional formula is to find the units. So, expression for derived quantity in terms of base quantities to describe its unit is called dimensional formula. Now, this is the dimensional formula, and square bracket the fundamental quantities are written and they are having some different powers based on the expression. Okay. So, this is the dimensional formula and these powers are the dimensions. Got it? Clear? No problem. So, note down this, pause the video, note down this. We will see the dimensions of different physical quantities now, important, and then we will see another part. Is it clear? Can I erase this? Now, look. Okay. Now, let us calculate dimension of area. Area. So, to find the dimension of any physical quantity, two things are there. One is formula and another is unit. Either one you should know, otherwise it is very difficult to write the dimensions. If you should know the formula, from the formula you can write the dimension, or you should know the units of that physical quantity, from that also you can write the dimensions. Okay. Okay. Now look, so many physical quantities you have studied in like mass, then acceleration, velocity, speed, area, volume, density, some basic physical quantity already you have learned in 8th standard, 9th standard or 10th standard. But there are many physical quantities which you have to study in class 1, class 11 and class 12, first year and second year of this junior college or pre-university college, PUC or HSC if you are Maharashtrian. Okay. So, and that is why this topic in many coaching classes, many institutions, this chapter is taught at the end of completion of the completion of the syllabus, at the end of the syllabus, because they will learn all the physical quantities and they think it is easy to do that, but we have to learn initially and at the end also. That is the best way. That is the best way. Okay. Now look, so you revise this at the end of syllabus also. So area is, we have to find the dimension. Area is what? Look, suppose there is a square. This is a square. Assume yaar, I do not have scale, but I will try. Okay. Let us say this is a square. This dimension is A, this dimension is A, this dimension is A. So area will be what? A square. If it is square, if it is a rectangle, A and B, what is area? A into B. You might be thinking, sir, we have studied this area and all that, why you are teaching again and again? But wait. So A means what? Length. So length square. Okay. Here also this is length, so length square. If you will talk about this circle, if this is a radius r, so what is the area? Pi r square. So this is a constant value and this is r means L and L square means again L square. You take anything, you take triangle, so this is the height of triangle and this is the base of triangle. So 1 upon 2 b into h, okay, so this is a constant L into L, so L square. So everywhere whatever may be the geometry, dimension or area is the length square. So dimension or base physical quantity in this is length twice, okay. So area is a length square, so dimension of area are what? m0, there is no mass m0, L2, there is no time 0. Normally I told you na, this is also correct. If you write this much, this is also correct, but normally we are habitual, our books are habitual to write in these 3 basic quantities, okay. Others also we can write A0, K0, luminous intensity 0 like that, but not necessary. These 3 you can write. So m0, L to the power 2, T to the power 0. So area has 0 dimension in mass, 0 dimension in time, but 2 dimensions in length. Got it? So this is what dimension of area. Clear? Clear? Then let us talk about speed and velocity. Speed and velocity are the 2 different physical quantities. Speed is a scalar, velocity is a vector. that we will learn what is the difference, exact difference between these two in another chapter, or I have uploaded one video on vector analysis, okay. You go to my channel, there you will find vector analysis. So, speed, but magnitude is same, magnitude of velocity we can say speed. Speed have only magnitude, no direction, but velocity have both direction and magnitude. But in dimensions we are not considering directions, okay, only magnitudes. So, both are equal, okay. So, both are distance upon time, So, L by T, okay. So, if you want to write dimension of speed or velocity, we can write like this: m0 L1 t to the power minus 1, yes or no? This is in the denominator, it will go in the numerator, it will become t to the power minus 1, okay, like this you can write. So, this is the dimensional formula for speed or velocity. It have 0 dimension in mass, 1 dimension in length, and minus 1 dimension in time, okay. Then you can have acceleration, A. What is acceleration? You have studied in 10th standard, yes or no? Tell me, what is acceleration? Acceleration is the rate of change of velocity, it is a rate of change of velocity, yes or no? Means for this much distance, if the body is moving for the suppose for 5 minutes, it is moving 10 meter per second, then in this for next 5 minutes or next 10 minutes it is moving with 20 meter per second. So, like this, suppose 25 meter per second for this remaining 15 meter or 15 whatever may be the time, okay. This is for 15 meter, 10 meter, 5 meter, so like this particular time will be there. So, this velocity is increasing with respect to time, okay. So, rate of change of velocity with respect to time, in detail we will discuss what is speed, velocity, acceleration, micro level analysis we will do in another topic, another chapter. Time being here, you just remember it is a velocity upon time, simple, velocity upon time, okay. So, what is velocity, dimension of velocity? Already we have calculated. If not, then we can use this formula and we can calculate. So, here already we have written, so I will write m0 L1 t to the power minus 1 divided by t to the power 1, okay. So, this we can write m0 L1 t to the power minus 1, this will be t to the power minus 1. So, ultimately m0 L1 minus 1 t to the power minus 2. So, what are the dimensions of A? Dimensions of A are what? m0 L1 t to the power minus 2, means dimension of acceleration is 0 in mass, because there is no mass is not required to calculate acceleration. It don't depend upon the mass, acceleration don't depend upon the mass, it depends upon the distance covered and time taken, yes or no. And acceleration having 1 dimension in length and minus 2 dimension in time, okay. So, this is what dimensions of acceleration. Clear, no problem in this. Are you writing or not? Stop your notifications, WhatsApp notifications, Facebook notifications, stop it, okay. Otherwise you download this video in your YouTube and then you watch, without internet also you can watch that. In that no ad will be there, no notification will be there, okay. I will stop the notifications. Another important thing is what? If the audio this video is not clear, on the top of your video there are 3 dots on the top, okay, on the screen. You click there, you will find 148, okay, 250 something I think, then 480, 720 like this, 1040, 1080 like this. So, normally if your internet is good, automatically it will take some resolution, but if not taking, if 148 or what is this, something is there 148 I think. So, on that you will see the blur video, Okay. So, you can fix on at least 480, on 480 you watch, it will be visible, otherwise 720 is the best way. Okay. If you have good network, then no problem, you can watch on 820 also, very clear video you will have, everything will be clear. My recording is okay, but depending upon your network quality you will have the resolution, depending upon that you will have the quality of video. Okay. So, next is next we will see the dimension of what, speed, area, speed, acceleration, then we will talk about force, we will talk about force. Can you write the dimension of force? Okay. What is force? Mass into acceleration, mass into acceleration, yes or no, mass into acceleration, m into a. So, dimensions of force is equal to mass, dimension of mass are m1, dimensions of acceleration already we have calculated, m0 L1 t to the power minus 2. So, this will be what, this m0 m1 m0, this power base same, so power will be added. So, 1 plus 0 is 1, L1 t to the power minus 2. So, these are the dimensions of force in terms of mass, length and time, 1 in mass, 1 in length and minus 2 in time. Got it? Clear? Clear? Clear force? You remember this force m1 L1 t to the power minus 2, because many times this force comes in picture, you must remember this, otherwise also you can calculate, but that will consume time, better you remember this. Okay. Clear? Then the next physical quantity is, let us say, work, let us say work, work. What is work? Force into Fs cos theta, no? So, here we will take force into displacement only. In work power energy we will discuss in detail what is work exactly. Here force into displacement is a work. So, dimensions of work, dimensions of work is equal to what? Dimensions of force. What are dimensions of force? Already we have calculated, m1 L1 t to the power minus 2, dimensions of S, displacement, S means displacement. So, dimensions of displacement means length, so L1. Okay. So, ultimately dimensions of work is equal to m1 L1 1, so L2 t to the power minus 2, these are the dimensions of work. Okay. So, these dimensions we have calculated by using formulae, and from that you can calculate the units of this physical quantity, or if you know the unit of these physical quantities and if you do not know the formula, no problem, from unit also you can calculate the dimensions of these physical quantities. How? What is the area, unit of area? Meter square, yes or no? If meter square is only meter square is there, so you can write the dimension, there is no mass, so 0, meter means length 2, so L2 t 0, same. What is the unit of speed or velocity? Meter per second, meter per second. So, meter there is no mass, so m0, meter means length, so L1 and s to the power 1, but in the denominator, so here that will become minus 1. So, from unit also you can write the dimensions. Like acceleration, acceleration is what? Meter per second square. So, m0 L 1, so L1 s divided by t to the power minus 2. So, ultimately this will go up and this will become plus 2. Okay. So, m0 L1 t2 t minus 2 will be there. So, from unit also you can calculate dimensions. Okay. In the same way force is what? What is the unit of force? Newton, but Newton means what? Kg meter per second square, this is called Newton, kg meter per second, because mass kg, acceleration meter per second square. So, kg meter per second square is a Newton. So, from this also you can write the dimension. Kg means mass 1, meter meter means length divided by s means time power 2. So, m L t to the power minus 2. So, 1 1 same is there, m 1 L 1 t to the power minus 2 same is there. Okay. So, from unit also you can calculate, like work joule. So, Newton second means what? This is displacement. Newton meter is called joule. Newton meter is called joule, and Newton is called what? Kg meter per second square into meter. So, kg meter square second square, this is called joule. Okay. So, from this also you can calculate kg means mass m1, this is length L2 divided by s square means t square. So, from this m1 L2 t to the power minus 2. So, m1 t2 t to the power minus 2 same is there. So, from unit also you can calculate dimensions. Clear? Clear? Then energy. Then energy. What is energy? See, in work power energy we will learn in detail. Potential energy, kinetic energy, chemical energy, mechanical energy, electrical energy, water energy, hydraulic energy, nuclear energy, lot many types of energies. Okay. But and so how to write the dimensions of energy? So, energy is basically what? Force into displacement. Whatever may be the type of energy, the work is stored in the form of energy. Work done is stored as a energy normally in mechanics also. Okay. So, and see, the formula unit of work is joule and unit of energy is also joule. So, remember, the physical quantities which are having same unit will have same dimensions. Physical quantities are having same unit will have same dimensions. So, joule. So, dimensions of energy will be what? Same as of dimension of energy will be what? Same, m1 L1 t to the power minus 2. Okay. This is also force into displacement. Or other type of energy, other formulas are there. From this also potential energy or kinetic energy. Kinetic energy is what? 1 upon 2 mv square. Yes. Yes. Let us calculate dimension of this. 1 upon t, unitless. Mass. Mass is what? m1. Velocity. Velocity means what? Meter per second. Velocity means what? Meter per second. Its square. So, m raised to 2. M raised to 2, s raised to 2. Okay. So, this will be what? This will be what? Here dimensions are 2, no? Work, what are the dimensions of work? 1, 2, 2 minus 2, 1, 2 minus 2, okay. So, s square. So, what are the dimensions? This mass is m, meter means length square. So, length square, second square means time square, okay. Time square means t to the power minus 2. Yes. From this also we are getting same. So, whatever may be the type of energy, kinetic energy, potential energy, any other type of energy, you will get same. Basically, it is a equivalent to the work. Clear? Clear? Any other physical quantity we can calculate is? Yes. Let us talk about momentum. Momentum. What is momentum? This force is equal to ma momentum. This we have studied in laws of motion. Again we will study in laws of motion. Okay. So, okay, momentum. 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 What is momentum? Mass into velocity. Yes, mass into velocity. Momentum normally written as P is equal to mass into velocity. So, dimensions of P or momentum, dimensions of mass m1, dimensions of velocity meter per second. Okay. So, meter means length L1, yes T1, T minus 1. Okay. So, ultimately what you are getting m1 L1 T to the power minus 1, correct na? Correct na? Look, mass m1, velocity meter per second, meter means length L1, Ts means time 1. So, L1 T minus 1. So, this will be there. So, this is the dimension of momentum. Clear? Clear? Okay. So, clear no? Now, let us calculate pressure, dimensions for pressure, dimension for pressure. So, pressure is what? Force upon area. See, force upon area. Force will come in many physical quantities. Force upon area. Dimensions of force are what? m1 L1 T to the power minus 2. Yes, correct na? Correct or not? Force. Force is equal to what? Mass into m into a, mass into acceleration, mass m1, acceleration, acceleration is velocity upon time. Okay. Velocity upon time. Velocity means what? Velocity, dimensions of velocity are what? Here we have written dimensions of velocity, L1 T to the power minus 1, L1 T to the power minus 1, okay, and divided by T. So, T2. So, m1 L1 T to the power minus 2 are the dimensions of force, yes or no? Divided by area. Area means L square. So, ultimately m1 L to the power 1 minus 2, yes or no? L1 T2, this will be L to the power minus 2, ultimately m1 L1, this 1, this minus 2 will become 1 minus 2 means minus 1 and T to the power minus 2. Okay. So, these are the dimensions of pressure. So, in this way you can calculate dimensions for different physical quantities. You must understand, you must know the formula or unit of that. From that you can find the dimensions. So, what we have covered today? We have learned the meaning of dimensional formula, then meaning of dimensions, that is power of the fundamental quantities to be raised. Okay. Then we have seen the different dimensional formulae for different physical quantities. Okay. I think this much is sufficient for today's lecture. In next video we will talk about principle of homogeneity, then uses of or applications of dimensions and limitations of dimensions. We will solve some numericals based on which can be asked in NEET and JEE also. Okay. So, till then study well, revise this video, note down everything. It is a very simple topic and very easy and very important also. Clear?